just keep everything. Okay. Okay, now question 6. The extension. Okay, everybody look at question 6. Now, the extension of a spring varies with the load hung from it. Okay, so basically, 它讲这一个 diagram shows the force and extension. Okay, but this one 这个 graph 是y 跟 x axis 的 balik 的。Okay, usually 我们是 y axis 是 force 的 but never mind, it's okay. Okay, now what is the elastic potential energy stored in the spring? Okay, now how do you calculate the elastic potential energy from the graph? Okay, now let me take my whiteboard here. Okay, just a short revision to recap some of the things we have learned last week. Okay, now 讲到 Hooke's law 呢，你想到什么 spring? Okay, spring is all about elasticity, spring. Now let's plot the graph of Hooke's law. Let's understand again what does Hooke's law really mean. Okay, so 这里我有 force and extension diagram. Okay, force Newton, extension. So we use x as extension. In cm. Now, let's say again, if I put a weight on it, 10 Newton, then you measure what is the extension of the spring, x. Okay, so 如果10 Newton, let's say 我 plot 10 Newton 这边，然后我拿到5 let's say 2 cm of extension. Okay, then you plot on the graph here. Okay, and then you add on the weight. 你增加那个重量，比如说你加去20 m, same. Then you measure again. 你增加重量，你再量那个 extension. Then you get, let's say you get 4 cm. Okay, so here you get 2 point, right? So 2 point here, 你可以 somehow imagine how does your graph looks like if this keeps on going, right? Now, from here, I can actually draw a horizontal line. So here, like this, right? I connect the 2 points together, so I get a straight line. Okay, so 在这里呢，你可以 somehow predict based on the Hooke's law. You can somehow predict if I add another 30 Newton, then what is my extension? Okay, so same, you plot it over here, then most probably you will get like 6 cm. Most probably. Why? Because you have a straight line, the gradient is the same. So in this case, 我们讲 the force is directly proportional to the extension. Okay, so this is what Hooke's law means. Okay, so the rate of extension and the rate of force, they are the same, they are proportional. Okay, so if I keep on increasing 40 n, same, so most probably I'll get 8 cm here. Okay, 40 n. So here, now of course 这一个直线不会永远都是直线的，对不对？不会永远都是直线，因为你的 spring 你 extend 到一个长度，它会开始lose its elasticity or start to break. Okay, so from here at some point your graph will look like this. Okay, let me draw, erase this. Your graph will look like, okay, let me erase this first. Okay, 从这里到这里是直线。Now maybe some point around here, it will start to curve down. Okay, it starts to go irregular shape, curve down. Okay, now the moment before it curve down, that point is usually we call it the elastic limit. Okay, elastic limit. So this is the limit to support the amount of weight you put in. Okay, so let's say this elastic limit is 10 cm. Okay, so here you have a 50 Newton. Okay, now beyond that, beyond this elastic limit, let's say 12 cm, if you keep on extending it, 12 cm 这边是 by right 12 cm 你的 force 也是应该是60的嘛，如果你是跟着那个 proportionality 的话，就是60 n 我会给到12的 extension， but 你会开始发现到 到这个12cm 的时候呢，你需要的 force 不用这样多了，可能是一个52 52 Newton 罢了。Okay, so you see from here 如果你看那个 x-axis 每一个 stage 我是加2cm 2cm 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 2cm， so the force also the same， 每一个 stage 我是加 10cm 10cm 10cm， so 会有一个时候当你会发觉到 the force only changes a little bit to get the same amount of extension. Okay, we are getting 2cm extension, 2cm, 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 but now the force required is a little bit less. Okay, so 2cm. So here you will notice there is a change. There's a change on the spring. So what happened is that when this happened, meaning that your spring is no longer in the elastic limit. It is now outside the elastic limit. So it starts to behave differently. It starts to disobey the Hooke's law. Okay, 它不会再跟 Hooke's law 一起了，不是跟一起了，就 it starts to disobey the Hooke's law. Okay, so we call that plastic region. So the spring is now in their plastic region. Previously, when they obey Hooke's law, we said that it is in the elastic region. Okay, so we are not interested in the plastic region. Okay, in this chapter, we are not interested in the plastic region. So anything that is beyond the elastic limit, we don't look at it. Okay, so we only focus at this one here. This one here, the straight line is where the Hooke's law applies. So again, what does the Hooke's law say? It says that the force and the string and the extension is directly proportional. Okay, 然后如果从这个 graph 呢，你算它的 gradient 哦 ，OK， 你算它的 gradient。Since 这个 graph 是一条直线，是 gradient 是一定是一样的嘛，不管你在哪一个 point， 它一定是 constant fixed gradient，right? So if you calculate the gradient, okay, you will get the what? You will get the spring constant， 就是我们讲的 K spring constant。Okay, spring constant. So the unit for spring constant is Newton/meter 或者 Newton/cm， 这两个都有用到的。Okay, Newton/meter, Newton/cm. So another way to think of spring constant is 你可以把它想成 stiffness. Okay, stiffness. How much force required to pull the string by 1 cm? Okay, if it's very hard, if it's very stiff, meaning that you have to put very large amount of force just to extend it by 1 cm. Okay, that is spring constant. Now, for this graph, so let me draw it again. So when you have this graph, force and extension, okay, so sometimes it can be like this. Okay, 我画两个这边 force extension， 这个是直线吗？然后如果你这个调转，有时候它会写这个 extension， 然后这个是 force。Okay, then you have to to write exactly this look like this， 差不多这样子，然后这个是差不多这样子。Okay, so you have to careful with the x-y axis and also the unit. Now we look at elastic potential energy. So elastic potential energy is the energy stored in the spring 当你 extend 或者你 compress 它。Okay, so the formula is 1/2 kx square, right? 1/2 kx square. Again, k 是我的 spring constant, x 是我的 extension. Now, so from here, we know that force equals to kx. Okay, this is the general formula of Hooke's law. Force equal to kx. So from here, you can actually substitute the x inside. So 1/2 这是等于 k 乘 x 嘛 x square. Okay, so I substitute this one, the force inside here. So 我会拿到1/2 force times extension. Okay, now if you take a look at this one, what does this mean from the graph? Okay, 从这个 graph 哦，你看如果我画一条线这里 ，Okay, so 这里我可以把它画成一个 triangle. OK， 画成一个 triangle. So this is the base, right? The base and the height. So how do you calculate the area of a triangle? Usually base 底乘高除2，是不是？底乘高除2呢？在这个 graph 里面呢，它的底就是它的 base， 代表什么？就是 x。Okay, because this is the x-axis 嘛。The x-axis, the extension. 高呢 the height here is my force. Correct? Is my force. So how do you usually calculate the area of a triangle? You take the base times the height divided by 2， 就是 fx 除2，也就是1 over 2 fx. So this one you will see that this one is the same as this one, right? 它是跟 elastic potential energy 一样的，所以我们可以讲 to calculate elastic potential energy， 我们就是要算 the area under the curve. Okay, the area. I repeat, to calculate elastic potential energy of the spring when it is being compressed, we look at the area under the curve of the graph. Okay, so back to the question here. Now, so 这里, so you have a graph here, and then how do you find it? So this is extension versus load. So what is the elastic potential energy stored in the spring when it is stretched by 10 millimeter? So 10 millimeter, you already have here 10. So 10 millimeter requires 20 N of force, right? So you just calculate the area under the curve. Now be careful, you calculate the area, right? You calculate the shaded region, this one over here. Okay, because x and y axis 是已经调转了。Okay, but actually you still get the same answer. You still get the same answer. So the answer here is A. Okay, 10乘20除2. But be careful that you have to change the millimeter to meter. Okay, you have to change the. 如果你直接拿10乘20除2，你会拿到wrong answer. Okay, you have to change this one 10 millimeter to 0.01 meter. Okay, so whenever you calculate energy, 当你要 calculate energy 的话 elastic potential energy, remember to always change to SI unit. Okay, cm 换去 meter. 可是你算 spring constant 的时候，你可以放在 cm， 因为 spring constant 是 n/m 或者 n/cm 嘛。OK， 比如说 3n/cm， 这个可以接受，你可以把它放在 cm。可是当你一算 elastic potential energy，make sure 这一个你要换去 meter 啊。So the final answer is 0.10 joules of energy. Okay, next one is number 7. Okay, look at number 7. Okay, now a spring having a spring constant of 100 Nm Gen E was used to launch a ball. So when launching the ball, the spring was stretched 10 cm. What was the kinetic energy of the ball when it was launched? Okay, so 这个就是 I draw it out here 啦，我画在这边。Okay, when you compress a spring, okay, this is the original. Okay, and when you compress it, it becomes shorter, right? Here, shorter. So this is the ball, and then you have your. Okay, 我画在那个白板，这里很乱。Original length of the spring, and after you put the ball, you compress it, becomes shorter. This is the ball, and this is the level, and this is the level, right? So this is the compression, or you can just call it extension lah. Okay, but you know that it is compressing down, right? Compressing down. So question 1, what is the kinetic energy? So from here, what is the concept behind this? 如果你按 you press down, the spring gains the elastic potential energy. Okay, when you press it down, because you're stretching it, right? Now, when you're still holding it down, the spring contains elastic potential energy that is ready to release. Okay, now the moment when you left your hand, you let go, okay, then the energy will straight away release and converts to kinetic energy, and it shoots the ball upward, right? So the concept behind here is that the elastic potential energy loss, because when you release, the elastic potential energy starts to straight away convert to kinetic, right? So it is lost, it's losing elastic potential energy. So elastic potential energy loss 等于 kinetic energy will say EK gain. This is our concept behind it. As long as you know this concept, then you can do this question. Meaning that 如果我可以算到 EP， 我就直接知道我的 EK 是什么。OK， 所以我的目的就是要算我的 elastic potential energy. And then we use what formula? EP equals to half kx square， 或者你也是可以用 EP equals to half fx is the same thing. Okay, kx square fx. Now， 如果比如说我加一个 extra question 问你 ，for example, I say, okay, what is the assumption made? How do you answer? What is the assumption made? Then you have to explain. Explain what? 你要解释这个东西。为什么你会 assume elastic potential energy loss equals to kinetic energy gain? Because 在真正的情况下是这个是不对的，就是讲 there is energy loss. Okay, there is energy loss in the real case. This one is just we assume. Okay, 因为如果我们不 assume 的话呢，我们的 calculation 会很复杂。Okay, 所以我们是要 to make our life easier 啦。We just assume that the EP loss equals to EK gain. So all the conversion of energy 我们都是 making assumption 的。Because in the real case it is much more complicated. Okay, it is much more that one we leave it to the scientists lah. Okay, we are just here to pass our exam. All right, so this one is actually our assumption. So if the question asks you what is the assumption made, then you say this one. The total amount of energy will not lose to the surrounding. Okay, the total amount of energy, or you can say, 或者你可以讲 the total amount of energy is constant in the system, is kept constant in the system. Okay, that's one way to say it. 或者你也可以讲there is no loss of energy to the surrounding， 你也可以这样子讲。或者你直接讲the energy loss equals to energy gain. Either of these three is acceptable. Okay, as long as you know the concept behind it. That is the assumption. So remember that 每次我们 calculate, we are making assumption, just that we didn't say it. Okay, remember that. Now, next one 就是 讲了一题，然后我就给你再 try 多一点 example. Okay, look at question 11. This one. Now, I just draw it on the whiteboard. Okay, let's say question 11 它给你三个 scenario. The first one is if okay 三个不同的scenario. So from here, 如果我讲 question 讲 what is the okay arrange the extension from the lowest to the highest. Arrange of the system from the lowest to the highest. Extension of the spring system from the lowest to the highest. So meaning that 你要找 which one gives you the lowest extension and which one gives you the highest. So you want to arrange in order. Now how do we do that? So let's revise again. How do we do that? Now from here, since all are having the same spring, okay, first thing you have to make sure 就是每一个 string 是一样的，就是它的 spring constant 是一样，它的 stiffness 是一样。The second thing is all the weight are the same. Okay, so they are the same. So from here, doesn't matter how complicated it looks. I always start with one spring. Okay, so your first job is to find what is the extension of this one spring if it is acted on by the same weight. Okay, so you take the same string, imagine that you draw it out, you draw one spring, then you want to find the extension of one spring. Okay, so since here 没有 value 给你嘛，是不是？所以你可以大概写，你可以写用 symbol 来代替。So here you have extension x here. Okay, let's take this is the original length. Let's say here lah, and then you put on the width w, then it gives you extension of x. Okay, but we don't need to know the value. Now, so one spring, same weight, extension is x. So if I combine these three springs in the first case, this is the first case, this is, we call it in series, right? It is in series. So the head connect to tail and then the head connect to tail. 这样子下，这个是 series connection. Okay, so for series connection, 记得 for series connection, 你的 extension 是这个 extension, 你要加这个 extension, 你要加这个 extension. Okay, so that will give you a total of 3x. Okay, 比如说如果你的 extension 是2 cm, then 你的这个 system 1会给你 total extension of 6 cm. Okay, it's 3 times. This is series. Now for second case,你有两个 parallel and then 一个 series, right? So 上面那两个是 side to side, so 上面两个是 parallel, and then 那两个是 series with the bottom one. Okay, they are series with the bottom one. So this one, how to calculate? So this one you calculate level by level. You have 2 levels here. Okay, this is the first level. Second level is the bottom one. Okay, like you regardless of 如果你的 system 是很复杂的，你就慢慢分第一个 level, 第二个 level, 第三个 level 啊，这样子比较容易。Okay, so level 1, you look at level 1, you have 2 parallel spring. So you take x divided by 2. Okay, so whatever is the extension, you divide by 2， 因为它是 shared by 2 spring. Okay, they shared by 2 spring. That is how the parallel works. Whatever extension you have, you divide by 2. So x divided by 2 这个，然后下面那个呢，你单单看下面那个 level bar， 它是一个 spring bar 嘛，是不是？没有 parallel 也没有什么，就一个 bar， 所以你就放 x 咯。Okay, the same extension for one spring. And then you want to add them together. So this one, you add this one. Okay, so level 1 add level 2. Because why? Because level 1 and level 2, they are series, right? You add them together, just like the first one. Okay, so x over 2 加 x 就是 1.5x 咯 1.5 1.5x 是不是1 2 2 3 3x 3对 1.5 Okay, so this system 2 will give you a total of 1.5 extension. How about the third one? Okay, the third one is just one level, right? Just one 一行罢了，所以你就单单算一行，所以这个是 x， 你的 extension 是 x， 这个你要除3，因为它是 parallel， 然后它有3个 spring， 所以你除3。So this one will give you 0.33 0.33 extension x. Okay, and then you compare which one will give you the least extension. Of course, 第三个是 extension 最小，第一个 extension 最大。所以如果我放如果你看那个 question 11，你的 answer 是 Z. Z will give you the lowest. Okay, let's say this is the Z lah. Last one is Z. This one is 第一个是 X, X, Y, Z. So Z, and then Y, and then X. Your answer is C from the exercise. Okay. OK， 我剩下1分钟，这里我们 log out 还有 log in， I will send the link again.